we are looking at some of the stuff that we've talked about before. I remember in the beginning of the semester I told you that trig identities would be coming back. We would be doing more with them, and that's why we needed to learn some of the things that we were learning at the beginning of the semester. So we are going to revisit those trig identities. So you guys remember the reciprocal identities and the Pythagorean identities? Those were on one of your early handouts as we began talking about our trig functions and the different things that we were learning in pre-cal after we got through with the review. So it's probably on your 5-1 handout. Now, if we were talking about the unit circle, we talked about how the equation of the unit circle was x squared plus y squared equal to 1, as 1 is our radius, right? And now we've been starting to use r. So now we can say that that unit circle equation is x squared plus y squared is equal to r squared. And now it doesn't only have to be 1, the equation could be r squared. So that can open it up to other circles, or triangles, that are outside of the unit circle. So let's talk about using our trig identities here. If we take sine squared theta plus cosine squared theta is equal to, well, sine squared is going to be equal to y over r squared plus cosine squared is x over r squared. Well, they have the same denominator. So let's rewrite this a little bit. Let's go y squared over r squared plus x squared over r squared. Now it's a little more clear that we have the same denominator. So we can then say that that is equal to y squared plus x squared over the r squared, because we just combined them over the common denominator. And then we can say, with substitution, since we started with x squared plus y squared equal to r squared, we can say that y squared plus x squared is equal to r squared on the top, and it's over r squared on the bottom. Well, r squared over r squared is 1. So with this respect, we've kind of proven that it's still equal to 1. It's just going to look a little bit differently, and it'll open up the possibilities of other trig that we can do with things besides just the unit circle or anything that happens on that unit circle. Alrighty, so the next thing we're going to do using our trig identities is we're going to express one trig function in terms of another. So we had something like this on test, the last test we had, test 1. So we're going to express one trig function in terms of another. All right, so let's express sine theta in terms of cosine theta. So we had one similar to this on our test, and the identity we're going to use will be the first Pythagorean identity. So the first Pythagorean identity is going to be sine squared theta plus cosine squared theta is equal to 1. So if we want to express sine theta in terms of cosine, we need to solve for sine theta. So I'm going to subtract cosine squared theta from both sides. So that will get me sine squared theta is equal to 1 minus cosine squared theta. Well, to solve for sine, I need to take the square root of both sides. So that'll get me sine theta is equal to plus or minus the square root of 1 minus cosine squared theta. Now, previously, like on our test, we were given a quadrant, but in this case we weren't. So what does that mean? Well, let's remind ourselves of the quadrants that we could possibly encounter and how. So the sign, not this sign, but the SIGN sign, depends on the quadrant. Okay? So if we are in quadrant 1 and 2, those are going to be positive because that's the y value, and in quadrant 1 and 2, the y value is positive. And in quadrant 3 and 4, it will be negative. So our quadrant 3 and 4 will have a negative value of sine. So this finishes up 6.3. Oh, not quite. Sorry. Looked at the wrong page number. All right, so a little bit more. We don't have too much more. So we're going to express sine theta in terms of another trig function. All right, so let's express tangent theta in terms of sine theta in quadrant 2. So if we're in tangent in quadrant 2, we'll have to think about whether that's going to be positive or negative. So let's first talk about what tangent theta is. If we need to do it in terms of sine theta, we need to write it to start with using something that is sine. Well, tangent is sine theta over cosine theta. So now we got to turn cosine theta into something that's in terms of sine. So that's going to be similar to what we just did, right? We did sine theta equal to plus or minus 1 minus cosine squared theta. Well, if we had instead solved for cosine, then sine would end up inside and cosine would be on the outside. Now we could spend the time solving this, but trust me, that's going to be how it is. We're going to go ahead and show it because I want you to know exactly what we're doing. But do try to make those connections that if I have our Pythagorean identity and I solve for sine, and so I have it in terms of cosine, if I need to solve for cosine in terms of sine, the only thing that will change is sine theta and cosine theta are going to switch places. So let's prove that. If I take my sine squared theta plus cosine squared theta is equal to 1, and this time I'm going to subtract the sine squared theta, then that will get me cosine squared theta is equal to 1 minus sine squared theta. So you see, as we've done the same thing but opposite, now we have cosine instead of sine, and over here we have 1 minus cosine squared theta. So to solve for that cosine, I'm going to take the square root. So I have cosine theta is equal to the plus or minus the square root of 1 minus sine squared theta. So now we have exactly the same thing, except our sine and cosines are reversed, depending on what we want to solve for. So at this point, we have sine or cosine written in terms of sine, so let's replace that into our equation. So we now have tangent theta is equal to sine theta over 1 minus sine squared theta with the square root. Is it going to be positive or negative? Well, cosine is negative. Cosine is negative in quadrant 2. So it's going to be negative because here we're replacing cosine with this. So now have we finished what we needed to do? Well, we expressed tangent in terms of sine theta. We've got sine and the negative the square root of 1 minus sine squared theta. So that would complete this problem. All right, so the next thing we're going to do is evaluate a trig function. So to evaluate a trig function, let's get that started.